Welcome to qnawire.
Okay, so we're being asked to find the vertical and horizontal asymptote of f of x. And so for vertical asymptote, we're looking at a function that's e raised to the power of the arctan of x. And e is an exponential function, and it is continuous everywhere, and it has no sort of vertical asymptote anywhere. It's not possible. I mean, it's not in this case. So we know that there's no vertical asymptote. So no vertical asymptote because it's an exponential function. However, for the arctan function, we do have asymptotes on the arctan function. So as a reminder, the graph actually looks like this. It has like a pi, and it kind of goes like this. So this goes off to pi over 2 and negative pi over 2. So this is pi over 2. This is not very drawn very well, but this goes off to negative pi. So there's a horizontal asymptote occurring in arctan x, and there's a very good chance that it's also occurring in f of x. So we are going to look at how the function behave as it goes off to infinity. So the limit as x goes to infinity. So what we're going to do is we're first going to evaluate it for arctan. So arctan x, and you'll see why in a second. And so the limit as the x goes to infinity of arctan of x, as you can see in this picture, is pi over 2. And so that means that the limit as x goes to infinity of f of x is going to be e to the pi over 2. So we do have horizontal asymptote occurring. And for the limit as x goes to negative infinity, for arctan of x is going to be negative pi over 2. So that means that the limit as x goes to negative infinity of f of x is going to give us e to the negative pi over 2. So we have two horizontal asymptotes. We have one at y is equal to e. Let me bring that down here. Y is equal to e pi over 2 and e to the minus pi over 2. To find whether the function is increasing or decreasing, we apply the first derivative test. That means we find f prime, and since this is an e raised to the arctan, we're going to have to do a chain rule, and so it comes out to be e arctan of x all over 1 plus x squared. And now, if you look at this function, we know that the exponential function is always positive, and we know that the denominator cannot be negative. So that means this function is always 0. It's always greater than 0. So it is always increasing. Always increasing. So that means it is increasing from negative infinity to infinity. And that means since it's always increasing, we know that there's no local min or max either, because there's no point in which the function is dipping either. So there's no local min or max. Now, for concavity, we look at the second derivative and see how f double prime is changing. F double prime of x is equal to e arctan of x times negative 2x plus 1 all over 1 plus x squared, and we set this equal to 0. E to the arctan can never equal 0, so we have to look at negative 2x plus 1 equals 0. Negative 2x plus 1 is equal to 0, and you get x equal 1/2. Now we do a sign chart. And we're going to evaluate it around 1/2. So if we look at the sign of f double prime, when it is less than 1/2, there's positive number. If it's greater than 1/2, it's negative number. So that means concave up, concave down. So it's concave up from negative infinity to 1/2, and then concave down from 1/2 to infinity. So, and also we have an inflection point. We have an inflection point occurring at 1/2 because that's where the sign change for our concavity is occurring. It's going from positive to negative. Now we have enough information to draw our graph. So this is going to be all above the x-axis because the lower bound for our horizontal asymptote is e to the negative pi over 2, which is still a positive number. So this could represent e to the negative pi over 2, and this could be e pi over 2 or something. So the function will actually look something like this. That will be coming up, and then at 1/2 it will switch and have a new concavity. So it goes from concave up to down, and that's basically the graph of f of x, except this is more straight. There's no local max or min. And that's it.